Hi, in this video I'm going to show you how to test an observed value of P for a binomial distribution where you have to use a normal approximation to a binomial. At the end of this I will show a bit of technology which will allow you to calculate the value, do the test for you as well. So it says here, a seller believes he has 40% chance of selling his product to a customer at the door. The company conducts a survey and randomly selects 120 households and 36 were sold the profit. Using a suitable approximation, test at the 5% level of significance whether or not the seller is justified. Okay, let X be the random variable, the number of products sold. Then X is binomially distributed, and there was 120 households selected, and the seller believes there is a 40% chance, 0.4 chance of success. If you convert that to a normal distribution, X will become normally distributed 120 times 0.4 by doing n times P, and then 120 times 0.4 times 0.6, which is np 1 minus p, to give you the two parameters of the normal distribution. This is the mean, and this is the variance. So X will be normally distributed of 48. Now the variance is actually 28.8, but as I've told you before, it's probably better to write it as like that, because when you come to standardize, you need the standard deviation. So forming the hypotheses, H0 P is equal to 0.4, there's a 40% chance, and H1 that P is not equal to 0.4. All we're asked us to do is whether or not the seller is justified. Okay, we're not saying less than or more than. So this implies that we're doing a two-tailed test at the 5% level. Calculating the test statistic, the probability that X is less than or equal to 36, well, because we're now applying a normal approximation, we have to do a continuity correction, so that means that X must be less than 36.5, applying the continuity correction. We're going to be using the standard normal variable, where Z is 0, 1, mean of 0 and variance of 1, and we will have to standardize using Z is equal to X minus the mean divided by the standard deviation. Therefore X will be normally distributed with a mean of 48 and a standard deviation of the square root of 28.8. The probability that X is less than or equal to 36 is that. So standardizing, we're going to get that Z is equal to 36.5 minus the mean divided by the standard deviation. This is why we write this like that. That comes out the probability that Z must be less than minus 2.1428. I like to draw a graph, so mean of 0 and standard deviation of 1 minus 2.142 is there. We want less than. So that means 1 minus, look up into table phi of 2.1428, because the table only gives positive values of Z, so we have to do this in sort of reverse to get that area. And when you look that up in the table, we'll look up 2.14 in the table, we're going to get 1 minus 0.9838, which gives me an answer of 0.0162. Now, because it's a two-tailed test, so the conclusion in 0.0162 is less than 0.025. It's 5%, but we're looking at 2.5% in that end and 2.5% in that end, because it's two-tailed. We have to split the 5% up. We reject H0 and say that the seller is not justified. We're going to reject H0. Now, it is possible to do this just by looking at the GeoGebra software and not even actually using the normal distribution. If you go to GeoGebra and go to the View menu and go Probability Calculator, and this normally comes out as a normal, so you need to set this to binomial. Set 120 P 0.4 less than or equal to 36. The actual value is 0.14. and it's illustrated here. Okay, this is the mean and the variance. If you apply a normal distribution, you get the normal distribution by clicking that on there. So getting that screenshot, so using the probability calculator in GeoGebra, x is binomially distributed 120, 0.4. These were the hypotheses. Null was equal to 0.4. P was not equal to 0.4. So we were looking at the probability of x being less than 36, which is that blue shaded area there. We would reject x naught if this area here is 2.5 and 0.25, but using the tables we'll see that is at 36, 37, somewhere in 38. And also you have to reject descent as well at the end of 58. Okay, this area here shaded is 1.49%. We get that from there, or 0.149. And again, we get the same conclusion. 0.0149 is less than 0.025. Reject 80. However, we cannot use this in an exam. We have to use the method indicated for the S2 exam. Okay, I hope you've understood this, and I thank you very much for watching.